see where are you from and what are you doing. Today I'm going to continue with the EIR Exchange Information Requirements Part 2. If you didn't watch yesterday's or the first part, you can see it here on BIM Voice. You can go to YouTube, to the YouTube channel on BIM Voice, and if you click on live, you will see here something called openBIM Harmony EIR Exchange Information Requirements Part 1. That's the one where I covered the first part of this document, and now I'm just going to continue where I left off, okay? So just so that it makes sense to you. And yeah, like I said, please leave a comment, and yeah, if you want other people in your network, maybe you have some friends that are interested in openBIM, then feel free to repost also this. Cool. Now I remember getting here to this table. You find this table in the spreadsheet version, Harmony 2.2, EIR BEP, tab, EIR IPMP, Project Information Production Methods and Procedures. So I'll just go very quickly over this. Number one, requirement, IFC standard. Requirements applied to IFC 4 and later versions. Models must be exported to the agreed version of IFC and object classes. Attributes and properties must follow the IFC standard. Oh my God, I love this. I love this because most of models are trash. Everything is stashed in the property sets. And yeah, this makes it so clear. And I love it. I love it because that's how you work effectively with using a standard, by following it, not creating another closed standard inside it. Doesn't make any sense, right? The project must use the agreed version of the IFC standard for object classes. Okay, custom attributes and properties should only be established if the agreed version of the IFC standard does not meet needs. Yeah, most of the time you will need them because there are some things that are not going to be covered in the IFC schema. But you should start with that. Don't create the custom property sets without even looking at what IFC has to offer. Georeferencing, EPSG and no rotation of model relative to map. Common local project point of origin. Local point of origin. A common local point of origin must be used for all discipline models. The model should be in the first quadrant relative to the 0 point to avoid negative numbers, which some modeling software can have problems with. The model should be placed at a distance from the 0 point so that all the model's parts are in the first quadrant. For object representing local point of origin, see number 10 in this table. Does that make sense to you? Let me launch Bonsai or Blender, yeah, and show you what this means. Concrete, because I think it's important. But yeah, I love everything what I see here. I'd love to hear from you. Like, how often you don't properly have georeferencing in place, right? And you get your models all across the place. It's crazy, right? It's really crazy. Yeah. Or tell me if you have mastered georeferencing, because that would be really interesting. Okay, so what this means, like in let's create an IFC project and add an IFC element and custom tessellation. Okay. Or let's do something else. Shift A and meshing cube. Okay, we got this cube here, right? What the main idea with what that thing said, the clause said, is that we should aim to have everything with positive coordinates close to origin, but everything should be positive, because there are some tools that are struggling with negative coordinates. So that means that your origin shouldn't be here, because if you have it like how, well, like when I add the new cube, you'll see, sorry, yeah, it's the same. It goes in all quadrants, right? And this is the positive one. This is the one with the positive X and Y. So that's why you should aim for that. So you should put first, yeah, you have to have the left corner of that building or a facility on the left-hand side, so you don't cross it into the ones with negatives, right? Not to the left, and not here, especially with everything negative, right? So that's kind of, let's see if this makes any sense. Yeah, like this, right? So here we have X and Y positives. like you can see here. And here we have negative x, and here we have negative y. So avoid these ones. Hope that makes sense. And let me know if not, and I'll try to explain one more time. Let's see if you have any comments so far. No comments. All right. If you have, let me know. And of course, say hello. Don't forget to say hello. Gross area, a space object specifying the building story gross area. SI, international system units must be used. Simplified model objects. Where model, this is extremely important, where model objects, discipline models, are particularly detailed beyond what is necessary for interdisciplinary planning, and this weighs down the performance of assembled models, the pointing party can demand the delivery of a simplified model that is used for assembly purposes. This is perceived as part of the delivery offered. Simplified models for special analysis purposes, energy analysis must be agreed at the conclusion of the agreement, or is to be understood as an additional delivery. Yeah, most of the time we don't need for coordination, and even for assembly or installation, we don't need all these details. These details are needed most of the time to create these objects, right? Or yeah, maybe to do other kind of trainings, like how to use them and so on. But if you want to see them, how you can assemble them and so on, you don't need all the fancy details. You need most of the time, yeah, the main elements, the screws and everything, fasteners and so on. So it makes sense. You shouldn't, because yeah, usually these pumps and these things coming from MEP models are extremely detailed, and yeah, IFC is not made to have very detailed geometry in it. Have parametric geometry as much as possible, and yeah, like for the normal objects. Horizontal division of room areas. Rooms that extend over several floors must have a separate room object for each floor. Okay, interesting. System affinity. Sorry, not interested. Interesting. That's correct, yeah. It should be separated by each floor. Apply to technical disciplines. Objects belonging to the same system must be grouped in the same system, either in IFC system or a relevant subcategory of IFC system. I don't know much about this. I didn't use it too much, so I'm not sure. But yeah, I guess what they say here, it's adhering to the IFC schema. Predefined subtypes. Use the IFC standard subdivision of object classes where applicable to specify class and subclasses. IFC covering flooring, where flooring is a predefined subtype of coverings, specifying that object represents a flooring. That's correct. Let's see, for example, if I remove this and if I add a new, let's try one more time, an IFC element. Let's give it, let's not give it an, I did an IFC type, that's why it didn't show. So let's take a beam, for example, and here, the predefined, these are the predefined ones, right? Joist, beam, hollow core, lintel, spandrel. Let's take this one, or a T-beam, for example, right? Yeah, so that's how you do it. And that's what it is. Like, it's already predefined. It's already in this category, right? And what do you do if you don't have it? Well, let me tell you that as well. You see? So this is the list of this in IFC4. Let's create an OFC 4x3 actually. A new project wizard. Let's take IFC 4x3 and let's add an IFC element, and let's look for the building, or let's take a column. And we have a column, pier stem segment, pilaster, stand column. If you don't have anything under these ones, then you create something using user-defined and you give it the name. But you should keep the same naming convention, like these ones, right? I don't know what name I could use here, but yeah, you can name, right? And then you will have that subcategory. But yeah, as IFC schema covers the starting point for us, right? By the way, sorry for starting a bit earlier, but I had to because I have some meetings after that and I cannot make it later. Cool. Local point of origin and control. Oh, this is a lot. Local point of origin objects must be established, which lies in the local point of origin coordinate, so that it is possible to visually check that all models are correctly positioned. Two control points object must also be established to ensure that models are not rotated. Coordinates of local point of origin and control objects are documented in part 3.1 BIM execution plan clause. Both 0 points object and control point objects must be represented by a pie slice. The size of the pie slice should be such that it's clearly visible when looking at the entire model, including the 0 point and the control objects on the screen. The bottom, so something like this. The bottom of the pie is at z equals 0, so no height. Each discipline gets a pie slice of 30 degrees. Starting in first quadrant, architectural, landscape, structural, plumbing, mechanical, electrical, and then not defined or whatever. Okay. So what's the story short of this? Two control points of almost, yeah. We have to use this thing, right? Discipline not specified. If more than 12 disciplines are needed, 12 additional pie slices can be established below this. The top of the pie slice is at height 0. Both 0 points objects and control point objects must be represented by a pie slice from each designing discipline. The size of the pie slice should be such that it is clearly visible when looking at the entire model, including the 0 point and control object on the screen. Local point of origin and control object is recommended as IFC entities, IFC annotation type enum survey. I think, is this in IFC 4? Or IFC 4x3? Let's see. Add IFC element type. No, that's IFC 4, because now we get other stuff, survey. We get some with the geometry, I forgot. No? Geographical elements, I think. Partial, I forgot. Yeah, well, I can look into that later. I don't want to digress now and go to another thing. Okay, cool. So we can go to the chapter 4. The project's information standard. General information shall be produced in line with the project's information standard to ensure successful exchange with other technologies using open data formats where possible. Try always. Always it's possible. Try harder if you don't know how to, or if you don't manage. Spatial breakdown structure. Information is delivered according to the model breakdown that follows ISO 16739 IFC. Story, IFC building story, will not normally be used in infrastructure projects. Yes, because there we have facility, we have bridge, and so on. We have facility and facility parts, which are for different parts of the site, but that's only starting with IFC 4x3. So that's why I'm thinking that this aims and is recommending always to use the newer schema. In construction, the model must relate to the project's common floor specification. All disciplines shall use the same information for each attribute. Information about values is provided by the client. Okay, spatial breakdown structure, or spatial decomposition, how I like to call it. You find this table in the spreadsheet. Yeah, we all have there as well. Project, IFC project has to have a project number and the project name. And the project number, it will be under the attribute name, and the project name will be under the long name. IFC site, cadastral number, site name, land title number, name, long name. This could be a nice video topic, actually. Could make a video once or a live stream, cover exactly how we do this with bonsai. Building, IFC building number and building name. Yes. So again, like the numbers or the not tags, but yeah, the numbers, the code more like are under the name, and long name is the full name of the building. And the same with the story and space. For space, we have space number. Okay, that's interesting. For space, it's a bit different. Space number goes under long name, space name goes under description, under the attribute description, and space function number goes under the name. Okay, maybe because this makes it easier to navigate and understand what's happening. Yeah. So this is the client who has to provide this. Okay, let's see if we got any questions. If you have any questions, guys, you are welcome to ask them. And you still didn't say hi. Say hi, come on. I'm kidding. You don't have to if you can't. So no worries. Let me go back. Naming conventions. Naming of model files and metadata. Model files must be named and specified with relevant metadata. See part 2.3 common data environment. Very interesting, right? So most of the time we will see the proper names of the models and files and so on, but these things right here are missing. These are the first things, and they are extremely important. Everyone just ignores IFC project and IFC site, even IFC building. Most of the time you will see some name that makes sense for the building story and IFC space, but that's a shame. We should treat equally importantly the other ones as well, starting with the project. Naming of building stories. The lead appointed party must establish a system for naming floors in collaboration with the appointing party and other stakeholders, including the user representative and the authorities. So technicalities, like how the names should be. The project information production method and procedures. The project information production methods and procedure describe the details of how information is to be produced, processed, and transferred through the project to ensure effective communication and coordination between all parties involved. Routines, interdisciplinary coordination, and model control. The lead appointed party must establish and maintain routines for interdisciplinary quality assurance of models so that the quality of models complies with exchange information requirements and that deviations are found and corrected. Interdisciplinary quality assurance must be carried out on an ongoing basis as part of the exchange and coordination of models. Quality assurance must cover all models in the project, including design subcontractors. Interdisciplinary quality assurance must also include final control in connection with the completion and handover of the project phase. This must include written documentation of the control carried out with a report from the model check and complete checklist from the responsible disciplines. How nice an IDS works for this kind of stuff. Routines for interdisciplinary coordination and model control are made available for the project and are referred to from the BIM execution plan. Process status coding. The appointed party. Oh, sorry about that. My sleeping hour is getting close. The appointed party must code objects to communicate maturity and suitability for use. The lead appointed party must establish a system for this, make it available in the project, and integrate it in interdisciplinary coordination and model control. The lead appointed party clarifies which codes are to be used and shares this with all relevant actors in the project. Revisions and version control. Very interesting, right? Something that we're still struggling with. The lead appointed party must establish a procedure for handling changes, revision, approval, and distribution of information to ensure that information is in accordance with the project's requirements before distribution, and there is no doubt about the current revision. Procedure, project procedure must include, or what? I don't know if this is a mistake or that's the intention of being written. Maybe it was here. Yeah, I'm not sure. Procedure must include complementary and agreed description of steps in the procedure, documentation of change history, specification of approval roles and responsibilities, methods for revision and distribution of updated files and models. Training and skills development. The lead appointed party must establish a plan for training project personnel, what is to be delivered, ER, how it is to be delivered, PEP. Everyone who must deliver on these requirements must be trained. This applies both at the start of the project and when bringing in new resources during the project implementation. I love it. The plan must also include systematic evaluation of procedures and regular updating of knowledge about current procedures and tools. Security procedures. The lead appointed party must establish a description of security procedures to ensure that the information is handled in a secure manner throughout the project's lifecycle. Proactive measures must be taken to prevent unauthorized access to information. 6. Projects Information Protocol. Legal aspects related to information are regulated in contract standards for consulting and construction. However, the parties should ensure that the following topics are adequately addressed: rights to use information, responsibility for information being correct, responsibility for information automatically generated by authoring tools, liability for use beyond the model's purpose, responsibility for storage during and after the project, ranking of contract documents, models, drawings, specifications, and relations between them, common data environment, change revision, and version management. Generic project stages. This framework uses the project stages from ISO 29481 Annex C as a common reference for adaptation to a national context. Use national project stage standard. Such an adaptation may include collapsing or splitting of stages in the reference table. Please note that any such changes may affect requirements in clause 2.4, requirements for alphanumerical information. Generic project stages. Inception, portfolio requirements establish the need for a project to specify the client's business requirement. Brief. 1. Conception of need. Identify potential solutions to the need and plan for feasibility. 2. Outline feasibility. Examine the feasibility of options presented in phase 1 and decide which of these should be considered for substantive feasibility. 3. Substantive feasibility. Gain financial approval. 4. Design. 4. Outline conceptual design. Identify major design elements based on the options presented. 5. Full conceptual design and all deliverables ready for detailed planning approval. 6. Coordinated design and procurement. Fix all major design elements to allow the project to proceed. Gain full financial approval for the project. Production. 7. Production information. Finalize all the major deliverables and proceed to construction. 8. Construction. Produce a product that satisfies all client requirements. Hand over the building as planned. Maintenance. Operation and maintenance. Operate and maintain the product effectively and efficiently. Demolition. 10. Disposal. Decommission, dismantle, and dispose of the components of the project and the project itself according to environmental and healthy safety rules. And that would be our ER, guys. We are through with it. Thank you very much for hanging in there. Hey. Hey there. Hey, Olivia. Thank you very much for hanging in there, guys. Nice meeting you again. Now, let's see what comes next, okay? That was the EIR part. I will continue with what is left from these documents. But I like a lot what I see. And I think these documents are going to be very useful for many projects that are going to employ BIM in the near future. Thank you so much for joining, guys. Thank you very much for all your support. And see you next time. Have a good one. Bye.